Okay, we're going to start the session from 3 p.m. by Himanshu. The title is Autonomous SOC, AI-driven supply chain security and software bills of materials remediation. Okay, please.
Thank you. Hello, konnichiwa, hajimashite. Yep. We will be talking about autonomous SOC, AI-driven supply chain security, and SBOM remediation. Introduction about myself. I'm Himanshu Sangshetti, and I would love to talk to you later, and we can introduce ourselves. But going to the topic. Yep. So let's talk about the current security issues that have been happening in the industry. So March month was really bad in terms of security. Why this has been happening is the speed of development has rapidly increased because of our AI developer tools, and we are not trying to monitor these properly. And March has proved it. In March, between March 19 to March 31, the software supply chain had 5 attacks in 12 days, which started from Chivi, that was March 19. Then it was Light LLM, March 24, Codex, March 30, Cloud Code, March 31, and Axios, March 31. Have you guys used any of these applications or softwares or heard of these? So these are pretty prominent ones. Cloud Code Codex has been our daily life use for engineering teams or developers. And the surprising part is that these applications or softwares being such prominent are currently facing security issues, and that too major ones. Let's actually go one by one to see what were these 5 attacks about. We can go to the first one, that is the Trivi. So what happened for the Trivi attack? The basic idea is Team PCP stole a personal access token from your Trivi CI pipeline. And what they did was they force pushed 76 of new version out of the 77 version tags. So what happened was any software or any organization that run through this tree actually pull the wrong versions or the malware versions of it. And this Trivy security tool became the own attack tool. You can scan the QR code to check onto the link, and that is the article. Now, this was the second one, Light LLM. Light LLM was the worst one. Light LLM is used as an abstraction for your AI calls. Almost many of your organizations or you as a developer must have used Light LLM yourself. Now, what happens is this Light LLM generates from the Trivy attack. Light LLM's CI ran the Trivy pipeline without any security. So now once the Trivy had an attack, it pulled the wrong versions in Light LLM. Then this wrong versions extracted the cloud credentials, the KDS configs, and all the environment variables from us. The third one was the Codex. Codex one was over the branch of your GitHub. So the basic idea in Codex was the branch name had invisible Unicode characters. And since the branch were unsanitized, the branch name actually run the code. So any code, any command you were putting as a branch name was actually running through that in the Codex environment. I think Claude Code was a pretty big security issue, which we saw. Claude on March 31st, the Claude code got leaked. Everyone actually downloaded the code on their own laptops and personal computers. The very simple reason why that happened was um, Claude uses bun as a packaging mechanism, and it bun generates .map files by default. So now this .map files should be ignored, which weren't. And that is the reason it actually exposed the whole code. And finally, Axios. Has anyone used Axios here before? Yep, pretty much, developers. So here, now, this is very related to talk which Edwin gave here, that static credentials and dynamic credentials. Now, the problem with Axios was they had a static credential for a long time, which was unchanged. Now, the static credential was exposed and was used to install a Trojan onto the Axios package. So these were the 5 attacks that happened in the month of March, and these were on to very high level securities issues that were seen. But the question is how these attacks happened. So out of these 5 attacks, we will see three of them in detail. If anyone has a problem with translation, they can go through the images, which can help you understand. So now going through the image itself, what happened in Trivy? A developer opened a PR to the code Aqua Security Trivy, and then this PR got a privileged run, which gives you the write access. Because of this write access, the PAT token or the permanent access token was actually stolen from a bot. And from that, the attackers rewrote the 76 tags. So this was the attacker side. If you see down on the purple, this is the user side. Now, we as users or developers use this trivia action without knowing about this. And this tag got silently directed to the new tags. And all the 474 repos pulled it and caused an issue. And this was the same thing that happened with Light LLM, because Light LLM pulled the wrong um, tags. So this single Trivi attack cascaded to multiple other softwares. And the major one was Light LLM and Telnex. The same thing to understand what happened with Light LLM. The same Trivi CI was run, and then the PyPI token was extracted from it. And this was published. When this happened, more than 1,000 environment variables were stolen. And from the system side, when we as developers were just running the Trivi, it actually pulled the malicious Trivi, and it used to download .pth file in your code, in your system, without your notice. And this would steal all the environment variables from your system. And finally, for your Axios, So here, your npm token was your npm token was stolen from the maintainer, like the static credential was stolen from the maintainer, and he published a malicious version of it, that is 1.14.1. So anyone who used this version 1.14.1 had a Trojan downloaded in their code. As developers, do you actually see which version are you downloading? Like, have you ever seen, like, if you are downloading 1.7 or 1.14.1? No. And that is the exact problem. The same three for 2 more weeks. And what is the main problem here? So in the current development, all the AI and developer tools hold elevated credentials and nobody is monitoring them. Each one of them downloaded a package which was auto-installed without a monitoring or without an approval and was run on your computer or like a system. We usually use multiple AI tools. We use Claude, Corex, Cursor. Does any one of you use these tools here? Just like, yep. So when your AI agent is running npm install, do we actually check what is it installing? No. And this is something that it auto approves or like auto runs, and we don't know what that AI is running. So currently, our AI or like our agents have these credentials to them. We have given the access to them. Question is it wrong to give them the access? Or is it wrong to give them the credentials? The simple answer is no. Because currently, towards the AI side, if you want to make systems autonomous or automatic, you would need to give them the credentials or the necessary requirements. So what can we do from our side? We can build a security around them. And now the funny part is all the attacks that happen already had the defense. By that, what I mean is all the attacks that happened and which I showed already had the existing softwares to stop them. But we were not using them, or we were using part of those softwares. And the basic concept here is we want to club them together and create an autonomous SOC where all your softwares are running together as a whole to monitor the complete security. This is the current problem which we have been looking for. The servers have monitoring and your pipelines have nothing. We have talked a lot about observability, monitoring, response, remediation for your production environments. But before the code goes to the production and the CI/CD is run through, that is where we have no security concerns right now. And that's the exact reason why we need an SOC, that is your Security Operations Center. A Security Operations Center in basic just means that all your security commands or your execution is in one place. And here, if as a simple human, when we try to solve a problem, we always do a four-stage thing. That is, first of all, we detect if there is a problem. Oh, if we detect, oh, there is a problem, then we analyze what actually is the problem here. Then we decide, is this problem high, severe? Should I immediately take a charge for it? And finally, respond to it, or we actually do the action to it. So we would like to see the autonomous SOC in the same four stages. That is, they detect, analyze, decide, and respond. If you expand these steps, we already have these softwares for it, and I have listed those here. So for any detection, you can use Swift, that is for SBOM. For analyzing if the list or the detection is actually vulnerable, we can use Gripe for the going through the CVEs. Then for deciding if it's actually is it critical, is it high, is it a medium level problem, you can use an AI agent or a policy engine. Like we can give it manual instructions. And finally, we can respond it by either blocking it, we can rotate our credentials, whatever the actual root cause is. So in general, we are kind of trying to do a root cause analysis and then get an answer to it. So this has been something that I have been trying to build myself, and we have also been getting some idea from the organization altogether. So the idea is to have 6 layers to your CI/CD pipeline for security. So has anyone used GitHub Actions here for your CI/CD or knows about it? Yep, perfect. Um, as we see, GitHub Actions is most probably used at a larger scale. We were trying to build this for GitHub Actions. So what the idea is, we'll have 6 layers to it, which has 6 associated tools. So the layers would be SBOM differentiation, vulnerability scanning, provenance, runtime, secrets, and AI triage. Um, to understand it in a very simple words, first is your SBOM diff. What does this mean? SBOM is software bill of materials. It basically lists down whatever packages or dependencies you have in your code. So whenever you do a SBOM over your code, you are basically listing all the packages or dependencies in your code. And when you see a diff, that means you are differentiating from the previous run onto what actually changed, which packages actually changed. And what Swift does that execution. Next is vulnerability scanning. Now we already have like data repositories online which list down these multiple vulnerabilities. So what it does is your Gripe, that is the tool, would go through these vulnerability scannings and your SBOM diff to understand if there is a vulnerability associated with it. Third is your provenance. Provenance is basically like an attestation or a signature. Whenever you are submitting your documents, um, most of the people would ask you to sign the document. So if you are submitting your passport, maybe they'll ask you to sign your passport Xerox so that they know that the Xerox is authentic. That is a similar idea here. That when your dependencies or packages say that, oh, yes, it is authentic, that means it has a provenance, that is, it has a signature to it. Fourth is runtime. Onto you are seeing what calls are going out of your code. Secrets is pretty obvious that your secret leaks. And finally, your triage onto you get all these layers together, throw it to AI and tell that, okay, these were the outputs. Now tell me what is the current remediation to it or solution to this problem. And if you can see, the previous 5 attacks, which we saw, could have been solved by just these 6 layers. And these have been mentioned onto how it can, like, at what layer it would solve it. If we just go through the Axios attack again, through these layers, if there was an Axios attack at Axios 1.14.1, which is the vulnerable one, when we did the npm install, it would run these layers. The first layer, hardened runner, would say, okay, I'm getting an outbound call to sfrclak.com, which is some website I don't know. SBOM diff would have told you that, okay, there is a new file or dependency getting created, which I don't know. And then provenance would say that, okay, Axios 1.14.1 is not an actual published package. We don't have a signature for it. And now, if there was an AI triage to analyze it, AI would say, okay, no, maybe this is severe. Let's block it. So this is the basic idea. All the attacks that happened or you saw right now, which were high level industry attacks, could have solved by just 5 to 6 tools which are already available. And it is just we as developers or organizations are using either part of it or not at all. And the idea is to build this in front of you. Let me go to the demo. So you can get a photo of this. This is the code of the demo which you would be seeing now. So the idea was to create an autonomous SOC, like all these 5 layers one by one. I hope the screen is visible. Okay. So each of the layer we saw right now, we have a separate action for it or a YAML for it, and we have a workflow for it, the way we define it in our CI/CDs. So for example, if you can see, this is your layer 1, where you are doing an hardened runner, where you are checking if there is an egress going out or if there is a call going out. So what your layer 1 says that I'll monitor runtime and sorry. Okay. And this is your hardened runner. So what it uses is it uses step security, where it says that whatever egress is going, you just audit it off. It's just like a 2-line thing, 3-line thing, which we are adding as the first layer. Overall, I would like to just show through you the code onto what we have right now. So this is like a GitHub action, which you can use yourself. These are the demos. You have like some demo files created for you where you have multiple scenarios. For example, we have a scenario for a secret leak, for any malicious dependency getting downloaded or any vulnerability dependency getting downloaded. The reason to have these scenarios is to actually create the scenario that actually happened for the March attack. And in your workflows, you have multiple files here. That is the layer by layer files. Your pipeline with 0 attacks or 0 defense, and then you have your SOC. So let's check your um, file with 0 protection. So this is your file where you're just trying to run npm install and npm test. So if you try to run this, let's run this for a scenario where we have a malicious dependency. So here it installs the dependency, that is the 78 packages. It just builds them and it says there is no security issue. And that is it. So this is our current pipelines which you see right now. The problem is if you see your current pipelines which we build, we are trying to do something like this, that we just do npm install, npm run build, npm test, and that is it. And we don't know anything about these packages. Now, if you go through these pipelines one by one, for example, like let's run the first one. So let's go to the actions again, the first layer, and let's trigger it for the malicious dependency. Your first layer was about runtime monitoring to check what egress or what requests are going out. So now in the same code, what you did was you installed, but before installation, you can see something like a hardened runner. So this hardened runner will give you a step security link, which would tell you all the outbound destinations. So if you can see here, it tells you that it went outbound for GitHub, for npm, but then there is one URL dot that is http bin.org, which is something that we don't know. And this is where you can monitor onto what egress is going out and make sure that not malicious code is going out. For the same thing, if you check for SBOM generation and differentiation, this would again follow the steps that now we have a hardened runner, which will check your egress. Now you are adding one more layer, that is that you would generate the SBOM. So here it generated the SBOM, and this is your differentiation. So the current has 78 components, but the earlier had 76 components. So it tells you that there are two new dependencies, and there is one plain crypto.js dependency which is unknown. This is a comment which I have added myself, but then this would show you the plain crypto.js which was unknown. So now SBOM would be useful to understand which are the new packages here. Now adding one more layer to it, that is the signatures. Okay. Okay, so it mentions that 77 packages has the signatures for it, but we have 78 components or 78 packages. So we don't have signature for one of the packages. So here you are confirming that whatever SBOM got the difference, you are saying that one of the packages is malicious because we don't have the signature for it. So this was your layer 3. Again, instead of going layer by layer, maybe what we can do is go through the complete autonomous SOC pipeline. That is your Yep. Let's go through one of the workflow to understand all of them, but you have reference to each one of the layers to understand what is happening. So this was our layers. Like what we are trying to do is we are trying to run the hardened runner. Just a second. Yep. So these were the layers we were building. First layer was towards the hardened runner, where you're checking the egress, then the SBOM diff. And if you go through the code itself, so the pipeline failed. So let's check why it failed. So it ran the hardened runner, where it checks for the egress, then it installed the dependencies, and now it's running the autonomous SOC. So what is happening here? Your Swift is used, your grep is used, your git leaks is used. SBOM is generated for 106 components. It can see 6 new dependencies, and these are the dependencies. Now it checks for vulnerabilities, and it says, okay, I can see 5 vulnerabilities here. The same way it will check for git leaks, and it's saying, okay, I can see 4 git leaks here. And now what this does is, whatever output you're getting from all these steps is given to your autonomous SOC or your AI to triage it. So you are giving it onto, okay, you can see some new dependency, and your AI would take a decision for you. That decision is that auto block onto it because the confidence is high since there are multiple critical issues here. So that is the concept of autonomous SOC. The basic idea here is if there is a malicious package in your code, the code should be able to detect it and stop it. So, but again, the problem is these were 9 steps of YAML. There were 9 YAMLs created, one for each layer, and then it was one for a complete package. So the question is, should developers actually keep on creating these 9 YAMLs for every project? So that's where the autonomous SOC comes in. So the basic use onto how you can use this is you can just add 5 to 6 lines of code. That is, you can use the existing repository. You can just tag the repository, and you can just provide the environment key or basically your AI key. Here, you can use multiple AI, that is your Claude, your OpenAI, or your Grok API. Since this is open source, if anyone from you is open source enthusiast, you can definitely go there, create some issues or create some PRs, and I'll definitely get connected with you guys. So now what this autonomous SOC gives you. So whenever you generate a new PR, it will automatically perform these 6 layers to it. And you as a developer don't actually need to keep on writing these layers. So you, as a developer, don't need to configure these 6 tools or manually triage across dashboards. So the idea is this is the start onto how autonomous SOC would look like. Here in the remediation, we are just using AI for understanding what is the problem right now. But how can this problem be solved is one other thing that we as developers can look onto. So something that is like, if there is a problem, AI should be actually able to use the tools and implement onto a safer version for it. Yep. And I think that is it about the talk. The major idea here was to explain onto what the security attacks have been happening right now, why security is a major concern, and how can you tackle security your way. There are multiple tools that you can use. All the tools shown here today were open source and free. So you as a developer or an organization can adopt it without any problems. And I think as a side note, I would mention that there was a solution that JFrog has mentioned or showcased outside. So you can see that too, because that solution is very similar or like has a same direction onto what this is about. But yes, thank you for hearing me out. Hope this was understandable.
We still have time. Any questions? Okay.
Hi, nice presentation.
Okay.
What will you recommend
Mm.
to the audience, like first steps, because there's like a lot of things to cover, but let's say that we have a project or a repository that we're delivering an application. In your point of view, what will be like the first step to focus and, a practical day one thing that we can apply as fast as possible?
I think the practical day one thing, as fast as possible, should be looking towards the credentials rather than the packages. The credentials thing is what you mentioned for the other talk onto making sure that you have like dynamic credentials rather than the static ones. Um, then also making sure your repositories don't have any personal access tokens. And then as the next step or as the starting step itself, developers can make sure the tools, the developer tools or the AI is monitored onto what packages are being downloaded. Since creating this complete workflow becomes a hassle for any developer. So as a quick solution, what they can do is making sure that you can have an approval system for these developer tools for installing any packages. And then onto if you are doing a rapid prototyping, then is something that you necessarily need these workflows out there. Yep.
Thank you. Any more questions? All right. Okay, then. Thank you very much.
Thank you.
Let's give a pause.